And we're back. This is lesson 46. I got my little quarantine creature going on here. Lesson 46, course 2. And in your table of contents, this is lesson 46 on rates and the distance equation. Rates and the distance equation. Get that written in. We're beginning on page 126. 126, rates and distance. Rates and distance equation. And I'm going to ask one of you to remind me about the secret code word at the end, okay? All right. So what exactly is a rate? A rate is just another way to write a ratio. Nothing more than a ratio. As a matter of fact, that's where we get the word rate from, is ratio. It is a ratio of two measures. So for instance, we might have a rate of speed, which is a ratio of 65 miles per 1 hour. We might have a mileage rate, which might be in my sweet little Kia Soul in city traffic, 25 miles per gallon, and I hope to shout I get a whole lot better than that. Or someone's pay rate, like if you're babysitting or working somewhere, you might get $12 per hour. Now what I want you to notice on all of these is that this is the per is always one something. At least when we have brought it down to what it should be, it is per unit of one. So miles per hour, miles per gallon, miles per 1 hour. All right, that's how they're written as fractions and how we think of them in words. Notice that the rate of speed is distance and time. So the rate of speed is distance and time. Your textbook on page 330 gives you this formula. The distance rate is equal to d over t, which means rate is equivalent to distance divided by time. Now there's another equation. When you think of this as distance, instead of thinking of it as the rate, we can also say that distance is rate times time. Rate times time is equal to distance. So for now, we're talking about ratios, so it would be similar to that. Distance is equal to then rate times time. So either equation. This equation right here is the one you will probably use most often, but for what they're doing in this lesson, that's the equation they're going to want you to focus on. All right, let's take a little example. We're going to talk about Arnold. And it says he drove 380 miles from Los Angeles to Sacramento. Okay? And it took him 6 hours to do that. All right? So then we want to know what is his average rate of speed. What is his average rate of speed? Well, if he did 380 miles in 6 hours, we need to figure out how many miles he would do in 1 hour. Okay? How would we do that? Well, you could do that as a cross product, and we would have 6m, or m, no, that's miles. It's just our variable. 6 times m will equal 380 times 1. and we know that our answer is going to be in miles, and in this case we would divide both sides by 6, so off we go. 380. Zoom out, Mrs. Rutherford, we can't see. Okay, 380 divided by 6. 6 times 6 is 36, with 2 left over. 6 goes into 23 times, which is 18, with 2 left over, and I'm thinking we may be having a pattern here, right? Oh, you know what? It's supposed to be 390 miles. So let's do a little presto changeo here. Got looking sideways with my glasses. 390 miles. That's going to make a difference. 390. And as we take care of this right here. So here we go. 390 divided by 6, because that's what we've got here. 6 times 6 is still 36, with 3 left over, and 6 goes into 35. And boy, doesn't that make it a whole lot better. So the miles would be 65 miles per 1 hour. 65 miles in 1 hour. That is his rate, 65 miles per hour. Notice the mph, miles per hour. Okay, now let's take that same trip, moving on to page 127. This is lesson 46, continued. Lesson 46 continued, and we're going to have Arnold on his same trip using using 390 miles, but this time he's using 15 gallons of gas. Okay, and we want to know his miles per gallon. So what is his MPG? That's the thing we want to know. So we're going to have to take 390 miles and divide by 15 gallons. And what will that be if we're taking it down to 1 gallon, 1 unit? And how much will that be? So we'll have 15x is equal to 390. Divide both sides by 15. 390 divided by 15. Well, that's similar to our other equation where we're dividing by 6. I'm going to put that into there 2, which is 30, and 9. Well, if it goes into there 2 times, and this is 3 times that, so this must be 6. 6 times 5 is 30, and it comes out evenly. So our x is 26, but what does that represent? It represents 26 miles per gallon. His gallon or mileage consumption is 26 miles per gallon of gas. Okay, that was a little better gas mileage. And then let's try one more with this. Let's take Jared this time. And let's say that Jared is paid $480 for working 30 hours. All right, so what would be his hourly rate? What is his hourly rate? Okay, again, $480 in 30 hours. We need to convert that to how much in 1 hour. Okay, so 30x is equal to 480 times 1. We're doing our cross products, remember? Divide both sides by 30, as we taught you how to do earlier. And we'll have 480 divided by 30. Gotta remind me, guys, somebody speak up and tell me to move the paper. Can't hear ya. Okay, well, 30 goes into 48 once. with 18 left over. And I think 3 goes into 18 6 times, so maybe right there, 6 times 0, 0. And 18 comes out even. So what is this? What does this X stand for? It's dollars per hour. So he's getting paid $16 per hour. And if he's a teenage kid like you guys, that's a pretty good rate of pay. That's a pretty good rate of pay. Seattle just recently passed that waiters and waitresses in downtown Seattle area get $15 an hour. So yeah, that's a pretty good rate of pay, $16 per hour. So something we need to know here is they're going to be talking about unit price. Unit price. And what is the unit price? Unit price is what it costs per one single item. One item. It's a ratio of price to quantity that is often posted in supermarkets to help customers identify the better buy. Now, one of many ways to express unit price is in cents per ounce. So, what is the unit price of a box of cereal? If we have a 24-ounce box of cereal, and the box of cereal costs $3.60. What's the unit price? And why would that be important? Well, so that I can compare. Is the 24-ounce box of cereal going to cost me less money than the 32-ounce box or the 48-ounce box? Is quantity a difference? Or what about if I only want to buy an 8-ounce box of the same cereal? Which one is going to be the better use of my money? So 24-ounce box of cereal is $3.60. So we're going to write this down, the unit price, $3.60 for 24 ounces. What does it cost for 1 ounce? Not for $1, but for 1 ounce. The unit of measure is ounces. And what is that cost? So we're going to do our cross product again. We're going to wind up with 24x is equal to $3.60 or 3.60. We're going to divide both sides by 24. All right, 360 divided by 24. It will not go into the 3. It will go into the 36 with 12 left over, and bring that down. What do you think? Do we go 5? Do we go 6? What might work? Well, I know that 12 is half of 24. What if we tried a 5? Because that's kind of like half of 10 and we're in decimals. 5 times 4 is 20. We have 10 plus 2 is 12, and it came out exactly right. So what does it cost per ounce? It costs 15 cents per ounce. Now, that might be important if I'm buying in quantity, but that's how it's done. We want to know per unit, the unit price. What would it cost? And it's time to flip over to page 128. This is still lesson 46, and it is continuing. Okay, so in many situations, we will be comparing the rate. Gina wants to know, let's switch gears here. Gina wants to know how much she will earn working 40 hours at $16 per hour. All right, so if she works 40 hours at a rate of $16 per hour per 1 hour, okay, how much will she earn? Well, if our rate is already per hour, this is in 1 hour, and if we want to know how much she'll earn in 40 hours, I hope you can see that that's just a simple multiplication problem. But we could do it like this too. We could do 16 over 1 hour is equal to how much money in 40 hours. Can you see that? And so then what do? If we do our cross product, it's the same thing. We're going to have that x, 1x, is equal to 16 times 40. So that's the same thing. If she works $16 and get for 1 hour, earns $16 in 1 hour, how much will she earn in 40 hours? You should be able to see that. It's just a simple multiplication problem. So I'm going to take my 40 and put it right here. I'm going to go a 0 for this one, and then I'm going to go 4 times 6 is 24. 4, 5, 6, and we have $640, don't we? Right there. We got that decimal that I didn't even include, but that's what it would turn out to be. She would earn $640. Now, just so you kids are aware that that's not what she would get to take home, because there's taxes and all sorts of other deductions that go along. So your $16 per hour for 40 hours, which is a 1 week at 8 hours a day, she's probably going to take home only about $580. At any rate, the math figures out to be 640. All right, let's try another little problem here. We're getting close to wanting to finish this lesson up, but we still have a ways to go. Linda's car holds 12 gallons of gas, and it gets on average 26 miles per gallon. Another way to write that is 26 mpg, right? Okay, I guess the question is, if she's going to make a 280-mile trip, will she reach her destination without having to refuel her car? What do you think? What should we do? If her car averages 26 miles in 1 gallon and it holds 12 gallons, how far will her car go on that 12 gallons? Let's try this. 26 miles in 1 gallon is equivalent to how many miles on 12 gallons? Okay, so we're going to have this times this and gallons. So the number of gallons that she will use, or miles that she can go, 26 times 12. So there's 2, 11, 300. She can go 312 miles. Now, if the trip is 280 miles and her car, I mean, that's burning it right down to the fumes, you know, emptying your tank completely. Would she be able to make this 280-mile trip without having to refill if she starts with a full tank of gas? She could make the trip. The word we want to use is likely to make it without refueling. Okay, make it without refueling. And likely to make it without refueling. Would that be wise? I don't think so. I think she probably should refuel somewhere along the way. But she could make it. All right, Shelley needs to drive. Shelley needs to drive 180 miles from her home near Fort Worth to Austin. So we're going to put down Fort Worth to Austin. Okay, it's a 180-mile trip. If she begins her drive at 9 o'clock in the morning and averages 60 miles per hour, when will she arrive? Oh, this is going to be kind of an interesting thing. Do you see how important it is to write down all of the given? She's taking a trip from Fort Worth to Austin that is 180 miles in one stretch. If she starts at 9 o'clock in the morning and goes 60 miles per hour, and that would be an average of 60 miles per hour, because you know good and well traffic and stoplights and other things are going to keep her from going that much more. How many hours will it take her to go the 180 miles? Let's set our thing up here. We've got a rate of 60 miles in 1 hour. How long will it take her to do 180 miles? How many hours? I thought my pencil was running out of lead. It kept sliding back up on the inside. So, good. Got that fixed now. If we do our cross products, we have 60 times x, which will be the hours, and 1 times 180. And you can see if we divide both sides by 60 that we will have x. This would be the number of hours. We can get rid of those zeros, and 6 goes into 18 how many times? 3, so hours to hours on the bottom. Her trip will be 3 hours, but they didn't want to know how many hours her trip will take. They want to know what time do you suppose she would arrive. Well, if she left at 9 in the morning, she would be there by what time? Can we say exactly at noon, or should we say about noon? Right, I think we can't say exactly, unless of course there's absolutely nothing impeding her way. But she can expect to arrive around noon. All right, let's take one more page, page 129. Boy, this lesson has taken a lot of pages. 129, we're still on lesson 46. Continued. Lesson 46 continued, and our thing now says, Felipe is planning a bicycle tour of the state with some friends. He estimates that he can ride for 7 hours a day. Felipe will ride for 7 hours each day and averages 12 miles per hour. Now, why would that be an average of 12 miles per hour? Well, because there's going to be some downhill strips where he may go faster and some uphill strips where he may be going a whole lot slower. And there's probably going to be some times when he stops to stretch or to take a potty break or to maybe even eat lunch. So on average, it's about 12 miles per hour. The question says, how far does Felipe estimate that they can ride each day? Well, here we go back to our distance equation. And remember I told you it was rate times time. Now they want that the rate is distance divided by time. And in this case, this equation, rate is 12 miles per hour. And the distance, we don't know, divided by 7. So we'll try that one in a little bit. But I like this equation so much better. We want to know the distance, and we know that he's going 12 miles per 1 hour at 7 hours. We can put that over 1, okay? So the hours will cancel the hours. Remember, a top and a bottom cancel each other. This is just a placeholder, so we're going to have the distance in miles. And you can see 12 times 7 and 1 times 1. So what is 12 times 7? They can expect to go 84 miles on average each day, if they do an average of 12 miles per hour for 7-hour days. They can expect to go about, maybe I should make that, about 84 miles each day. What about this equation over here? What if I took the rate and then the distance over time? Let's convert that equation. We know that the rate is 12 miles per 1 hour, equivalent to the distance that's unknown divided by the time, which was 7 hours. What would we do here? What would we do here? We would do our cross products, and we're going to get D equals 12 times 7, which again is our rate times our time. Do you see how this equation actually, when you do cross products, does convert to this one right here? All right, guys, well, I hope that you have learned a lot from this lesson. Oh, thank you for reminding me about the magic word. I know some of you are just waiting at the end for it. The magic word today is green monster. Green monster. This has been lesson 46.